Hi friends, this is Atanu Chaudhary of SureSolve. Today in the first part, we'll take up the SSC CGL solution set 19 on trigonometry 3 from suresolve.com and solve the first 5 questions. Let's solve the first of this difficult set of problems. Question 1 is, the value of the product of tan 1 degree, tan 2 degree, tan 3 degree up to tan 89 degree is option A root 3, option B 0, option C 1 and option D 1 by root 3. From complementary trigonometric function relations we know that tan pi by 2 minus theta equal to cot theta, where theta is an acute angle. With this knowledge we find in the product a matching partner of tan 89 degree in tan 1 degree. As tan 89 degree equal to cot 1 degree, the product of the pair results in just 1. We have tan 89 degree equal to cot 1 degree and so tan 1 degree multiplied by tan 89 degree equal to tan 1 degree multiplied by cot 1 degree equal to 1. Likewise, we tick off the pairs tan 2 degree and tan 88 degree, tan 3 degree and tan 87 degree, continuing up to the pairing of tan 44 degree and tan 46 degree. Each of these pairs contributes 1 to the final product result. The total number of pairs will be 89 plus 1 by 2 minus 1 equal to 44. In other words, the product has 44 times 2 equal to 88 terms, with one term, the middle term of tan 45 degree equal to 1, left alone without any pairing. So, 1 multiplied 45 times with itself is just 1. Answer is option C 1. Next problem. Question 2 is, the value of cot 18 degree multiplied by cot 72 degree cos squared 22 degree plus 1 by tan 72 degree sec squared 68 degree is option A 1 by root 3, option B 3, option C 1 and option D root 2. Here also, using the complementary trigonometric function relations, we observe presence of only two numbers of distinct values of angles, because cot 72 degree equal to tan 18 degree, tan 72 degree equal to cot 18 degree and sec 68 degree equal to cosec 22 degree. So we decide to transform all functions to these two distinct values of 18 degree and 22 degree. The target expression is simplified as E equal to cot 18 degree multiplied by tan 18 degree cos squared 22 degree plus 1 by cot 18 degree cos squared 22 degree. Equal to cos squared 22 degree plus sin squared 22 degree equal to 1. The factor cot 18 degree has been multiplied with the two terms inside the brackets. Answer is option C 1. Next problem. Question 3 is, if A sin theta plus B cos theta equal to C, then the value of A cos theta minus B sin theta is option A plus minus root over minus A square plus B square plus C square, option B plus minus root over A square minus B square plus C square, option C plus minus root over A square minus B square minus C square and option D plus minus root over A square plus B square minus C square. The plus minus in the choice values indicates the solution will need first raising the given expression to the power of 2 and then taking the square root. But the key pattern we discover is the middle term of the square of the given expression 2ab sin theta cos theta is same as the middle term of the square of the target expression, except for reversal of sign. At this point, the solution could be clearly seen. First raise the given expression to its square. We have A sin theta plus B cos theta equal to C, or A square sin square theta plus 2ab sin theta cos theta plus B square cos square theta equal to C square. To convert a square sin square theta to a square cos square theta and b square cos square theta to b square sin square theta at one stroke, now subtract both sides of the equation from a square plus b square. A square multiplied by 1 minus sin square theta minus 2ab sin theta cos theta plus b square multiplied by 1 minus cos square theta equal to a square plus b square minus c square. Basically, we have changed the sign of both sides of the equation to negative and then added a square plus b square to both sides without disturbing the equality. So, a cos theta minus b sin theta whole square equal to a square plus b square minus c square. Or a cos theta minus b sin theta equal to plus minus root over a square plus b square minus c square. Answer is option D, plus minus root over a square plus b square minus c square. Next problem. Question 4 is the value of cos square theta multiplied by sin theta plus cos theta divided by cosec square theta multiplied by sin theta minus cos theta plus sin square theta multiplied by sin theta minus cos theta divided by sec square theta multiplied by sin theta plus cos theta whole multiplied by sec square theta minus cosec square theta is option A 1, option B 2, option C 3 and option D 4. The expression looks very awkward, but we detect a pattern in it that should solve the problem very easily. When we looked at the two terms inside the brackets, we could immediately discover the likely hidden factor of sin square theta cos square theta for both the terms. Just invert cosec square theta in the first term and sec square theta in the second. This is the key pattern discovery, and immediately we multiply the factor through the brackets of the second factor sec square theta minus cosec square theta. This is transformed to just sin square theta minus cos square theta. For your easy understanding, we write down the result at this stage. Sin theta plus cos theta divided by sin theta minus cos theta plus sin theta minus cos theta divided by sin theta plus cos theta whole multiplied by sin square theta minus cos square theta. Now we'll multiply back the two simplified terms inside the brackets of the first factor by sin square theta minus cos square theta. The denominators cancel out, leaving sin theta plus cos theta whole square plus sin theta minus cos theta whole square. This is a familiar summation. The middle terms cancel out and the result becomes simply 2 times sin square theta plus cos square theta equal to 2. Answer is option B 2. We don't really need to write anything for solving this problem in maximum 30 seconds. Last problem then. Question 5 is tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta is equal to option A 1 minus tan theta minus cot theta, option B 1 plus tan theta plus cot theta, option C 1 minus tan theta plus cot theta, and option D 1 plus tan theta minus cot theta. We identify only one unique variable in the expression, that is tan theta equal to 1 by cot theta equal to x we substitute for convenience. Instead of two variables, you now have only one to deal with. You have applied the powerful variable reduction technique. The target expression becomes E equal to x by 1 minus 1 by x plus 1 by x by 1 minus x. equal to x squared by x minus 1 minus 1 by x multiplied by x minus 1. Equal to x cube minus 1 divided by x multiplied by x minus 1. Now we'll use the algebraic expression x cube minus 1 equal to x minus 1 multiplied by x square plus x plus 1. X minus 1 gets cancelled out and the direct expression is simplified to E equal to tan square theta plus tan theta plus 1 divided by tan theta. We have reverted back to the original value of x as the complexity is not there anymore. E equal to then 1 plus tan theta plus cot theta. Answer is option B, 1 plus tan theta plus cot theta. None of the 5 problems is easy, but each can be solved quickly in mind by discovering key patterns and using the methods for utilizing the patterns. To read the detailed solutions, refer to the article in suresolve.com. Link is given in the description of this video. And please do subscribe to our channel for latest uploads. Thanks for watching.